You still there? Did I lose you? Okay, I heard it beep, and sometimes that tells me that I've lost the connection. Okay. I'm sorry, what? Oh, you left the meeting? Oh, I'm talking to you, but you're not in the go to meeting. Okay. Huh. It still shows you as in the meeting. No, now it shows you in there again. In fact, it shows you in there twice, and it will take the offline one out of there. So, can you see my screen if I write a number? Like, tell me what number I'm writing. Oops, hold on. That's not. You still there? What number did I just write? Okay. All right. So we've got the meeting going. Okay, that seems to be fine. So what do you got? Okay. So this is a division problem. It's a good thing because we would not be able to factor that numerator. That would be like a 45-minute problem to factor that numerator. That's how hard cubics are. But to divide a cubic by a linear term, which is the denominator, it's actually pretty easy. We can do it by long division or we can do it by synthetic division. You pick. Okay, so if I'm going to do synthetic division, something goes in the box. What is it? No, it's whatever the zero is. So what's the zero if x minus 8 is a factor? It's 8. Okay, so that's what goes in the box. Now, what goes up top? Tell me what to write. Okay? Mm-hmm. Now we're adding. Now we're adding all the time. The advantage of synthetic division is you get to add instead of subtract. If we were doing long division, we'd be subtracting every step. But with synthetic division, we're adding. So that's -3. Okay, now what? Yeah, in fact, we're multiplying and adding instead of dividing and subtracting. So it's the exact opposite of regular division. And it's much easier. It's much easier to multiply and add than it is to subtract and divide. Okay. Yeah. the fact that that is 0 is very significant. The fact that it's 0 says that x minus 8 divides into this polynomial evenly. What is, if it was a number, it would say x minus 8 is not a factor of that polynomial. Okay? So if I would have done it this way, long division, what would my answer be? In other words, what would that be up there? You can tell from the synthetic division. In other words, the answer is in there. What is it? Start from the left. Yes, you do know. What does that 1 mean? Yeah. One advantage, I guess, and one advantage of doing the audio by phone is that I know what's going on. If we were doing the audio by GoToMeeting, I'd really be probably talking and nobody would be on the other end listening. So, that's all right. Okay, you're back in. Okay. Unfortunately, I erased everything I had. It was x minus 8, correct? And the top was 1 minus 11, 14, and 8, 80. And we got 1, 8, minus 3, minus 24, minus 10, minus 80, producing a 0. And the question is what is the answer? When you divide that original polynomial by x minus 8, what is the answer? And this is the answer right there. Just got to know what it is, what that means. Remember, we're dividing by x minus 8, and that is x cubed. So what's that first 1 going to be? X squared. When you divide a cubic by a linear, you get a quadratic. What's the next term going to be? The first term is 1x squared. That's what that 1 means. Minus 3 what? And that's the answer. It's not that it's equal to 0. It's that we had a remainder of 0, which is really important. That means this, that when I divide by that polynomial, by that, if I were to do it long division, my answer would be x squared minus 3x minus 10. Therefore, that times that equals that. But notice that when you do the synthetic division, you get your answer. You just have to know that that's an x squared, that that's an x, and that's the number. What else you got? Okay. Like that? minus 6. Like that. Okay. Give me the first step. What's the easiest first step? You got two possible first steps. One possible first step is to multiply both sides by 25. But that means we're going to have to multiply 25 times 6. The other possible first step is to add 6 to both sides. That gets rid of that. Which one do you think is the best one? Yeah, because what does that give us? What's minus 2 plus 6? All right, so now we have that. Now I can multiply to get rid of that denominator. But notice, I don't have to multiply 25 times 6. I have to multiply 25 times 4, which is a lot easier. So what's the next line? Really? Huh. Do you have a pencil and paper? Yeah, I don't know what's going on either. Write down x squared over 25 equals 4. Now solve it. Tell me the next line. You're getting rid of, always get rid of parentheses and denominators. How do you get rid of that denominator? By, okay, it gives me x squared equals 100. That's the next line. Now, what's the next thing to do? Can you see my screen? Do you see that x squared equals 100? If you don't, write it on a piece of paper. In other words, as long as you have a piece of paper in front of you and we can continue to communicate, I think we can accomplish the same thing, whether you keep getting kicked off a GoToMeeting or not. And I have no idea why that would be the case, but we can work around it if we have to. Okay? So you got x squared equals 100. You got to solve for x. What's x equal to? Almost. Single biggest mistake made by every high school student I tutor. It's plus or minus 10. Whenever you're taking the square root of both sides, you have to put a plus or minus. Always begin your answer with the words plus or minus whenever you're taking the square root of both sides. Okay? Because notice why minus 10 is a proper answer. Minus 10 times minus 10 is equal to 100. Therefore, minus 10 is a square root of that. And plus 10 works also. 10 times 10 is also 100. But both of these are 100 when you square them. So that's why you always need the plus or minus sign. And you can take either answer, plus 10 or minus 10, stick it into this equation, and it will still be an equation. And that's the ultimate test. Okay, can you see my screen? Okay, what's next? You might want to write it down. If you're going to keep getting knocked off, you might want to write it down so we can just kind of pick right up. Okay. I had trouble on Tuesday. My internet, there was an internet outage in my house, my neighborhood. I had 3 sessions, and some of them had finals the next day. I had to go to Starbucks to conduct those sessions. That was brutal. So what's next? That's it? Okay. Let's take it term by term. How do I do that? Square root of negative 64. Whenever you're taking the square root of negative numbers, what's the very first step? Well, you got to remove the negative 1. In other words, the square root of negative 64 is the square root of negative 1, that's what I'm removing, times what? That is a true statement. You can always take radicals and separate them into 2 steps like that. And that is equal to what? What's the square root of negative 1 equal to? That is I. What's the square root of 64 equal to? And we always write it with the I last. In other words, that becomes 8I. So that's 8I right there. Now, this is also going to be an imaginary number. Every time you take the square root of a negative number, you're going to get an I. Okay? But it's not condensed. Here, let me erase what I've got down below. Let's talk about what the square root of negative 21 is. It's first step. It's left. It's not negative 21 or it's negative 121. That makes it a little bit more understandable. So it's negative 1 times the square root of 121, correct? Okay. What's the square root of negative 1? What's the square root of 121? It's not 10. It's 11. So that's 11I. Nice of them to give us ones and i's all in the same answer. Okay, so what is that? What's 8I plus 11I? That's your answer. What else? Brandon, you still there? What else? Extraneous solutions. Okay. Okay. When you have a normal equation like this, you rarely have extraneous solutions. You don't even have to worry about them. There are three types of things that give you occasionally extraneous solutions. Radical sign is one of them. Absolute value sign is another. And logarithms is the third. Okay? So I'm looking at two radical signs here. So I want to be on the lookout for extraneous solutions. And as all that means is that once I solve this, I'm going to go back in and I'm going to substitute both solutions and make sure that everything is still true. Okay, so what's the first step in solving this? Radical signs are like parentheses and denominators. You want to get rid of them. How do you get rid of both radical signs? Tell me the next line. You're squaring both sides. Well, whenever you take the square root of x and you square it, you get x. Always, no matter what it is. If it's the square root of 17 squared, that's 17. If it's the square root of 172 squared, that's 172. So no matter what is inside the radical sign, if I square the whole thing, I get what's inside the radical sign. Always. That's the only way we can solve these kind of equations, is because when we square both sides, we get what? When you square a radical, you get whatever's inside the radical. You get what's inside the radical. That's what's inside the radical. What's the other side? Next line. Very good. I like it that you did both steps at once. That's a very, very common thing you have to do when solving equations. Is exactly what you did there. What you did there was you moved all the x's to the left side, you moved all the numbers to the right, you did it in one step. So what's x equal to? Okay. Now, let's go back and look at our original equation, and let's make sure that 3, when I substitute 3, it works. Does it? Yeah, you get square root of 13 equals square root of 13. So everything's fine. Okay, what else you got? You're bound to have one that has some extraneous solutions, otherwise they wouldn't have warned you about it. So keep going. First step. There's two possible first steps. What's one of them? That's the better one. In other words, when you have a radical sign, in the equation like that. Your goal is to get it isolated. Well, we already have it isolated. In other words, I don't want to add 6 because then I wouldn't have it isolated anymore. So I definitely do not want to add 6 to both sides. I want to square both sides. Okay? So I'm going to square that side, and I'm going to square that side. Tell me what the right side's equal to first. What's the left side equal to? Squared. What is that equal to? No. No, that's the second most common problem. Seriously. Here's what you're doing. That's what x minus 6 times x minus 6 means. Or that's what x minus 6 squared means. Now FOIL those. It's not x squared minus 36. FOIL them. You won't get that. What do you get? Okay. That's x squared minus 12x plus 36. Completely different. So be careful in making that mistake. It is a common one, where a person, when they see a binomial squared, they instantly want to say x squared minus 36. No, it isn't that, ever. Okay? Now what? What are we looking at? Aha! That's the key. We're looking at a quadratic. When you're looking at a quadratic, and it has an x squared term in it, and it has an x term in it, and it has a number, how do we solve it? Before you factor, you got to get one side of the equation equal to what? Okay. Which side of the equation is going to be equal to 0? No, I'd have to subtract 3 different terms to make the left side equal to 0. I only have to subtract 1 term to make the right side equal to 0. What is it? So what's the next line? Nope. Okay. Now you have it in the form that we can solve it by factoring. In other words, if I can take this quadratic and factor it, then I'll know that one of those factors has to be 0. Not necessarily both of them, but one of them will have to be 0. Factor that. Step by step. Signs next. Both signs. You said minus on both sides? Good. That's correct. Because minus times minus is going to produce that plus that's in front of the 36. And the reason it's minus minus and not plus plus is because of the minus that's in front of the 15. Okay? So, now what? The third step will give you the answer. Verbalize it for me. What are we looking for now? I'll start you off. Perfect. That do what? That add. Whatever that sign says. If that's a negative sign, then it's factors of 36 that subtract. If it's a positive sign, it's factors of 36 that add. Okay, well, let's look at factors of 36. Hold on. I think that's all of them. Which factors add to 15? And it doesn't matter which one I put. I could put 3 and 12 or 12 and 3. So in this problem, there's only 3 steps, and it's the 3 steps we did. The only time there's a 4th step is when it's a negative sign in front of the number. When it's a negative sign in front of the number, then the 4th step is deciding which factor goes with the positive sign and which factor goes with the negative sign. Okay? Now, what 2 answers does that give me? Okay, let's try 3. 3 minus 6 is what? Square it. And now substitute 3 on the other side. Hold on a second. I didn't mean to square it. Excuse me. In fact, that screws the whole thing up. This was our original equation, was it not? It's just that in solving it, the first step was to square it. I got that in there. But this is our equation, correct? Right? Was x minus 6 equals square root of 3x? Okay, so substitute 3. What do you get on the left? Nope. Nope. On the left, x minus 6. Substitute 3. Now substitute it on the right. Nope. Do a substitution first. You get the square root of negative 9. Excuse me. You get the square root of positive 9. What's the square root of positive 9? Those aren't equal to one another. That means that is not a solution. Let's try 12. Almost certainly one of them is a solution. It's just frequently one of them is not. So when you substitute x equal 12, what do you get? On the left. What do you get on the right? You get the square root of 36, which is what? Aha, so that one works. So that is our only solution, 12, to this equation. Even though when we solved it in a normal way, we came up with 2 solutions. But remember what the principal law of algebra says. It says that when you have 2 things multiplied together, this one times that one, that's equal to 0, it says one of them has to be equal to 0. It doesn't necessarily say that both of them have to be equal to 0. And the only one that really is equal to 0 is that one right there, x equal 12. This other one is not equal to 0. It's equal to 9. In other words, this solution didn't work. And so that's what they're talking about when they talk about extraneous solutions. And again, you tend to find them wherever you see radical signs. Not always, but sometimes. Can't assume that just because there's a radical sign, you're going to get an extraneous solution. So you need to actually check all your solutions to see if they work. What else? I had you down for an hour. We've gone for 40 minutes. We can do whatever you want. Having a hard time. Your audio went blurry all of a sudden. Like that. It's under the square root like that. Okay. Again, when you see an equation that has a radical sign in it, your goal is to isolate it. Once you get it isolated, then you can square both sides and go from there. Well, again, it's isolated. If I had a plus 21 added to it, well, I'd want to get rid of that 21 before I square both sides. Because when you square both sides, you really have to square both sides. You can't just square the parts you want to square. So, what's the next line? Got to square both sides. In other words, you got 44 minus 2x by squaring the left side. You can't just square the left side in an equation. If you square the left side, you got to square the right side. So what you're really doing is this. You're squaring the left side and squaring the right side. Now don't make the same mistake you made last time. How do you square the right side? Okay. Do it on pencil. Do it on your pencil and paper in front of you. You don't have to do this in your head. You can write it out. Hold on. There's two minus 10x's there, and then the plus 100. So it's x squared minus 20x plus 100. Notice that can be done in one step. You don't always have to FOIL those. Whenever I have a plus b squared, I automatically know it's going to be a squared plus 2ab plus b squared. 2ab here is 2 times x times 10. So that's where you get your 20. Okay? So whenever you see a binomial term squared, think of this formula. And you can do it in about half the time. The middle term is always 2 times that term times that term. That term times that term is minus 10x. 2 times that is minus 20x. Okay? All right. Now what am I going to do? Hold on, let me finish writing the left side here. So now I'm looking at this. Direct me. What are we looking at? What are we looking at? What kind of an equation? Okay, how do you solve quadratics? You have to put 0 on one side. That's the key. You have to make one side equal to 0. Well, which side am I going to make 0? Okay, how do I do that? No, the right side is already a pretty nice looking quadratic. We just got to do something with that 44 and that minus 2x. So what do we do with them? Let's go term by term. We're still going to have an x squared. How many x's are we going to have? When I move this over to the right side, how many x's? Okay. Now I got to move this 44 over to the right side. 56. Okay. Now that's equal to 0. That's what's left. That's always the way you solve quadratics, is to get him looking like that. Always equal to 0. At least when you have an x squared term and you have an x term and you have a number. If it's any other combination, there's other ways to do it. But most of the time when you have a quadratic, you're setting one side equal to 0. Not always, but most of the time. Okay, again, we got to factor that. Take your time, do it slowly the way I've taught you. Step 1. Step 2. Step 3. It's not 8 and 7, first of all, but let's look at the number 56. Factor that. What's the next set of factors I'm going to get? Keep going. And if I cut 28 in half, I got a double 2. Okay? Now, verbalize the third step. You're looking for fact of what? Verbalize the whole thing for me. Okay. Now we have to check both solutions, because again, we have a radical sign. And let me get back to the point that we started, which is that. Hold on, let me just erase that and make it read x. It's x minus 10, correct? Yeah. So that was our original equation. So, and you don't always have to check these. But when you're looking at a radical sign, you do. Okay. So, substitute 14. What do we get? That's 6. Is that a true statement? Okay, so that is a good solution. Now let's try 4. No, 4 does not work. You end up with 6 equal minus 6, which is not true. Okay. What else? Like that. Or is it x? No parentheses? It matters, because with the parentheses, both the x is being squared and the y is being squared. Without the parentheses, only the y is being squared. Okay, that's what parentheses do. Is if you don't have them, the only thing the exponent acts on is the thing that it's above, only. Okay? In other words, on top, both the x squared is being taken to the fourth power and the y is being taken to the fourth power, but the 9 is not. Okay. First step. Do your numbers first, and then your next variable, and then the next variable, and then the next variable. There could be 17 variables here, and it would not be a tougher problem. So what are the numbers? What is 9 over 45 equal to? One-fifth. 45 divided by 9 is 5. Okay. Now, let's get rid of those parentheses in the top. So let's, in order to get rid of the parentheses, we have to do that action there. What do you get? Nope, you don't add. We are not multiplying anything here. We are double exponentiating. When you double exponentiate, you multiply your exponents. When you just do straight multiplication, if I was doing x to the second times x to the fourth, then I add. Okay? But if I'm doing x squared to the fourth, that's completely different. That's x squared times x squared times x squared times x squared. So you're going to multiply there and get x to the 8th. Okay? So that's x to the 8th. Y what? And the denominator, we'll just write it like that for the moment. Okay, so we've simplified the numbers. We've gotten rid of the parentheses in the numerator. Now let's simplify the x's. We still got the 1 and the 5. What is this? X to the 8th divided by x to the 1st. What do you do when you're dividing? What do you do to the exponents? Okay, so what's the answer? Very good. And the y's. And there's your answer. Now, I don't really need this 1, so let me erase it. But I do need the 5, and it needs to be in the bottom of the denominator, like that. Okay? So that's your answer. In other words, you can't simplify that anymore. That's it. Now, if I would have ended up with a negative exponent on one of these variables, I would have moved it to the other side. Not just exponent, even if it was on the number, I would have moved it to the other side. In other words, if that ended up being my answer, then I'm going to make it look like this. Understand? If you have a negative exponent, just move it to the other side of the fraction bar. Even if it's in the denominator to start with, move it to the numerator and change the sign on the exponent. All right, what else? Can't quite understand you, Brandon. What? Okay. correct? Okay. The one thing to know you can do is turn that into x squared to the negative 4 divided by y to the minus 2 to the negative 4. See what I did? Just separated it into a numerator and a denominator. Now, what's the numerator become? No. What are you going to do to those exponents? Okay. So x to the minus 8 all over what? Now what do you have to do? Because your teacher says no negative exponents. Perfect. All you need to remember is your 3 rules about exponents. Let's just review them because they're so important. You can't get any of these correct if you miss them. Okay? So, tell me the answer to these 3 problems. What's that one? That's the only 3 rules you need. Notice when you are multiplying, you are adding. When you are dividing, you are subtracting. And when you are double exponentiating, you are multiplying. It's the only 3 rules you need for exponents. But the base has to be the same. In other words, if I give you this problem here, what's the answer? No. The bases have to be the same. The only time that ever works is if I have an x and an x. Well, I don't have the same bases here. I have a 2 and I have a 4. So that is not simplifiable. In other words, these 3 rules over here only work if it's the same base. If it was 2 to the 3rd times 2 to the 5th, then the answer is 2 to the 8th. But if it's different bases, you can't do anything. Actually, technically, I could do something. Let me point this out. Well, how can I write 4? What's another way to write 4? About 2 squared. Is that the same thing? Okay. Yes, it is. 2 cubed times 4 to the 5th is the same as 2 cubed, and I'm just writing 4 in a different way. I'm writing it as 2 squared. So now I got 2 cubed times what? Multiply exponents. You're doing double exponentiation. That's this scenario over here. Okay, what's 2 to the 3rd times 2 to the 10th? You're multiplying. What do you do with multiplication? You add. Make sure your things go together. Multiplication goes with it's 2 to the 13th. Multiplication goes with addition. Division goes with subtraction. And that's the answer. In other words, the only reason I was able to do that problem was because 4 could be represented as 2 to some power. If that's a 6, then I can't do the problem. I cannot represent 6 as 2 to some exponent. I just happened to be able to with 4. I accidentally picked 4. I didn't mean to. I just accidentally picked it. And because it was a power of 2, then I was able to express 4 as a power of 2, and then I could continue to use my rules of exponents, because all of a sudden now I have the same bases, base 2. So I don't know if they'll give you something like that, 2 cubed times 4 to the 5th, probably not, but you do get those kind of problems on the SAT test and the ACT test. So it's definitely something you're going to run into sooner or later. It's when you have numbers that are the same base. In other words, if I had 9 to the x equals 27 to the 2x plus 3, well, those aren't the same base, so it looks right off that I can't solve it. But, I can write 9 as 3 squared, and I can write 27 as 3 cubed. Now I got everything in base 3. I got 3 to the 2x equals 3 to the 6x plus 9. And if I got 3 to one exponent equal 3 to the other exponent, I can say 2x equals 6x plus 9 and solve that for x. So occasionally, even when your bases are not the same, you can still make progress if they have a common exponential base. In this case, 9 has an exponential base of 3, and so does 27. All right. Brandon, I'm going to let you go. Good luck. I'm sure you're going to be ready for a vacation in Hawaii by the time tomorrow comes. Seriously, as hard as finals week is on me, I know it's much tougher on you and all my students. I can't even imagine taking finals in like 5 different subjects. No, it's got to be brutal. So good luck. Have a good Christmas and New Year's, and maybe we'll talk to you next semester. All right, Brandon. Bye-bye.